And hello, everyone. We are back on this awesome YouTube channel all about Kotlin. Roman, you should unmute yourself, I think. So I'm Anton, and I have Roman today with me, and we are going to talk about Kotlin notebooks and everything Kotlin for data analytics, including some awesome libraries that the team is working on, like Dataframe and Kandy for plotting nice graphs. And Roman is going to show like how to start with notebooks, and we are going to show you a nice little demo by analyzing some data about the weather. So hello, Roman. Can you hear me?
Hello, can you hear me?
Yes. Yes, I can hear you perfectly. So you are from Amsterdam, right?
Right, and you are from
I'm from
Tallinn?
Yes, both cities are famous for its weather, and we're
Well,
gonna analyze weather data today, right? So how's weather like in Amsterdam right now?
well, today is I'd say celebration of sun. So the weather today is like amazing. Yeah, hello
Okay.
everyone. Hello everyone, and how's the weather today in Tallinn?
Well, for me, it's miserable, no sun, it's fog, it's cold, it's humid, so it's really bad. So, folks who are with us on the chat, tell us where are you from, and is the weather, what's the weather like today for you? So, Roman, I was looking at this Kotlin notebook plugin for a while, and I actually tried it a little bit, but I think not so many people have seen it, and not so many people have tried it. Where do we start? What should we do? Like, could you give us a little introduction to the subject?
Yeah, well, first of all, like Kotlin Notebook plugin is a plugin for IntelliJ IDEA, and like it's page on Marketplace, and currently it's compatible only with IntelliJ IDEA Ultimate Edition. Hopefully, we'll be able to relax this limitation in the future, but it's like currently we have lots of technical issues with that because we heavily depend on the platform. So now I'm jumped into the IntelliJ IDEA, and it's like freshly created project. And if I open plugins, you actually like can find this Kotlin Notebook plugin in the marketplace and install it. It will automatically install several plugins together with it. One is Jupyter, and another one is Python. And actually, like, don't be afraid of it. Like, no Python will be installed on your computer. It's actually just some dependency we need for working with the Jupyter notebooks. So essentially, Kotlin notebooks are Jupyter notebooks. And if you never heard about Jupyter notebooks, it's actually absolutely not a problem to start. So it's just some standard, which is currently de facto the main format on the market for notebooks. And Kotlin notebooks just follow this standard. That's why we like actually, and if we create a new notebook in our project, let's call it like our first notebook, add it to the, it's just a file. So we edit it to our version control, and you may notice that it has IPyNB extension.
Yeah.
Yes, and it's for a reason. Like it's actually it's IPython notebook, but it's Kotlin notebook. And you may ask why it's not like KTNB or something like this. But the thing is that we decided to left this extension for compatibility, for example, with GitHub. So GitHub know what is IPyNB, and like looking at the extension, it then renders these notebooks as a notebook in the GitHub web page. So what is notebook? Notebooks is a very handy and simple format of writing code and writing and documenting, and actually you can document not only code but the way of your thoughts. So let's start from the very simple thing. For example, currently you see it just have one prompt here, and it's the first cell of our notebook. Notebook is divided to to cells, and it's very handy, and later you will understand why cells concept is useful for iterative development. Okay, so let's do something. For example, we can write 10 plus 10 and use it as a calculator. The first cell running a little bit slow because it's you have to start Kotlin compiler behind the scene and so on. But now, when it started, yeah, you can run it again, and it's runs instantly. The thing is, what actually happens? First of all, how I run the cell. You have several options. You can click run cell here, and it's shift enter, or you can click control plus enter and run it and stay in the same cell and get the result. So every cell has its content and the result, which is actually output of the cell. So the last expression you have in a cell is actually output of the cell. So if I write something like this, the output will be 200. This one is also calculated, but we lose it. So what else we can do? We can, for example, create some variables and then use them. So if we use L or L plus M, and it's more or less like a simple Kotlin REPL and so on. So it's very, very simple. Of course, all standard library is also available. For example, we can write print hello YouTube.
I actually have a question.
Yep.
So you started with a existing project, which is, I see, a Gradle project, and it raises the question: does it have to be some sort of Gradle or Maven project with the dependencies, or I can just start with empty project and just create this little file?
Yeah, this one actually was empty project. So if we open this main thing, it's actually a empty Java project, which is just created. So you can use Maven, you can use IntelliJ IDEA build system. So any build system which is supported by IntelliJ IDEA works with notebooks. The cool thing is that you actually can have the dependencies of your notebook inside the Kotlin notebook. So you can depend on the classes which are defined in the ordinary Kotlin files, which is
I see. So the class path. So the class path of the project is available in my notebooks. I can use the same classes, right?
Exactly. Not only class paths of the whole project, libraries, right? But also here's a small thing here, and you can actually select libraries, and by default they all are selected, which actually already used in your project. So use all project libraries. And also you can select modules from your notebook and from your project, and select modules and use them as a dependencies for your notebook. And you can use classes which are defined in the project. And so it's very handy playground for experimenting. So it's like some like small assistant where you can play with your classes or with libraries that you use and so on. It's very similar to concept of Scratch if in IntelliJ IDEA. But the
Mm-hmm.
difference is that first of all, it's like has lots of outputs, and later we all understand that they are quite powerful. And another thing is actually scratches are like you have scratches here in the like not in the version control. So notebook can be created under scratches, or it can be created in version control, and then you can like use it, reuse it later, or share it with your colleagues. Good. So what else? Like there are lots of applications for notebooks, and developers can find in Kandy like for prototyping, experimenting with libraries, for working, for example, with HTTP, like as HTTP client, playing with some REST APIs, for writing documentation, and also important thing like actually for sharing it with others in the web. And we'll later take a look at it. But today, like we want to focus on one very like narrow but common case, which is called data exploration, data analytics. So something like playing with some piece of data. And this piece of data can be like literally anything. It could be JSON, it could be some CSV file or some database. And we will start from the very like basics, and then go further to some like quite tricky stuff. Okay, so let's explore also a little bit about like Kotlin notebooks, just to better understand. I hope that actually many of you already know it, but just to show it. Like, first of all, if I click escape, then you see this stripe becomes blue, and I can navigate through cells, and it's called common mode. So if I click enter, press enter, then I go inside into edit mode. In command mode, I can do lots of things. For example, I can, with option click, I can move the cell, or for example, I can change the type of cell. If I click M, it will be now markdown cell. Actually, all of the stuff can be, of course, be changed from the menu toolbar, but like, yeah, so, and you have two types of cells, like cell with code and cell with some markdown. So I can, for example, write intro and list item 1, okay, and list item.
So that's awesome. You can have like documentation alongside the code rendered nicely, and probably with some pictures and diagrams as well.
Yeah, exactly. Let's try it, for example, to show a picture. And to show a picture, you can actually show it inside Markdown, or, which is also a nice thing, any output can be output of code cell can be HTML. So if, for example, I here write something, now it's rendered as HTML. It's not visible, right, that it's HTML. So let's create, for example, image. So let's have image with source, and here I say link 1. And some funny reason, I see no output. What's wrong with it? Because I haven't closed the deck. Yeah, it's quite big. So let's add something like width 40. Cool. There is an image of like nice kid playing with laptop like me today. And so I can have it like this, or for example here I can have a link, and like in Markdown, and it will be a link too. And yeah, let's click on it. And it's opened, but like in the wrong browser. Let me switch to this browser and click on link again. Again, it opened in the wrong browser. What the? And if it will be the last browser I used. Nope, again in the wrong. Okay, I'll move it somehow to the okay, the problem is that I have two browsers, one for streaming and one here. Okay. Oh, and it's actually linked to Netherlands Times.nl, which I read from time to time. And actually, it was a picture from news. And the news is that Dutch people set new data record at Amsterdam Internet Hub. And it was because of the bad weather, which is quite funny. So it was like several days ago. And indeed, it was terrible wind, like really like a storm. Probably it was Storm Lewis or something, but it was like really strong wind with horizontal rain. And well, I moved to Amsterdam from St. Petersburg, which is known for awful weather with lots of clouds and so on. But like, and I was like expected that I'm actually prepared for any weather conditions. So I was so wrong. Amsterdam,
it's very different.
was like, it was above all my expectations. And today, actually, I want to analyze, like, actually, I have one more link here. Like, let's add one more link, which is a link, link 2, which is, oops, link 3. And hopefully this time, oh yeah, now it works. It's also news from the same NL Times, and that October, actually last October, likely wettest on record rainfall to continue over the weekend. So, and the text of news is that October was the wettest month ever observed in Amsterdam. And that like the totally it was 180 millimeters. And the previous record was 193 in 193 too. So
yeah, like almost 92 years ago, 93 years ago. Can we verify that?
Kind of. So the thing is that the October was awful, as well as November. Like I remember that it was like something like a constant rain every day. But let's check it. That's like two things that I want to check today. So actually, probably let's check if it was really so wet, and probably mass media like say us not completely the truth again. So let's check it today, and it's actually going to be our task for today. So I already downloaded a small CSV with all the weather starting the millennium, and it was like actually measured every hour. So if you open CSV file in the IntelliJ IDEA, you can actually click here on data, and it will be automatically opened as a table, which is quite like nice feature. So you can now explore it. For example, you can like, I don't know, like take a look at temperature and sort it and see that the highest temperature was 32 degrees and the lowest temperature was 2.3. I'm, to be honest, not sure about it, but like it seems, at least I remember temperatures even like lower than this. So probably it actually takes just a small piece of data when it deals with big CSV. There are also like some drawing capabilities. For example, you can draw a line and take X as, for example, daytime and Y as temperature. And it looks very strange because there are only 3 points. Yeah, just 3 points, which is quite strange, to be honest. So not every time I'm happy with this chart capability. It's pretty fresh and new. So that's why let's try to do it in Kotlin Notebook today. Okay, so let's open our notebook and let's navigate to the last cell. And let's just drag and drop our CSV file here. And it automatically generate the code which is needed for actually read this CSV file. So let's take a look at this code. So first I will delete in control mode this empty cell. Use Dataframe. So I have to stop a little bit on this. So actually, like notebook is like has some dependencies. As we already said, like it has some dependencies from the like project you are working on, but also you can like define any dependencies inside. And there are like multiple ways how to do it. And the most simple one is just use like magic, and like in notebooks it's called magic. And then you can like select one of the most commonly used libraries in notebooks, and this list is growing and growing. And here you can select, like, for example, Dataframe, or I don't know, like, for example, I don't know, Exposed, or KHTTP, KMAS, wonderful library, and like many others. For example, we can use here Kandy because we'll need this library for visualizing our data frame later. And when I run it, it will automatically create a like it will go to Maven Central, download the binaries. It will add some imports, so you don't need to import, like, for example, here Dataframe was already added when I use this use Dataframe. So if we take a like deeper look, we can actually take a look at this. Like for Kotlin Jupyter, okay, here there's a list of libraries, list of supported libraries in libraries repository. So every repository is like in this repository, there are lots of JSON files, which every file defines how the like particular library will be added. For example, here, like we have this data frame JSON, and here is defined what dependencies should be added, And actually, Dataframe has like a little bit different integration, which is like embedded right inside the Dataframe. But if we take a look at, for example, I don't know, like probably Multic, yeah. So it's like a list of dependencies, lists of imports, link for the repository, and so on. So it's very handy way to specify the dependency. On the other side, you can always specify just Maven coordinates of your repository. It's as for me, it's always a little bit weird, but you can always do it. For example, like you can write something like depend. Oh, I even forgotten how to do it, so I'm not really often use it. Let's take a look at documentation. Depends. Okay, file depends on and then coordinates. So you can write something like file depends on, and here something like I don't know, like let's add cater, cater HTTP engine, and add some, for example, Apache, something like this, and like specify this thing. And
probably 2.2 or something, 2.2.0.
Why it should actually create this variable. I don't know why it doesn't work. Okay. Yeah, it should be 2. I don't know what's the current one. 2.3.8. 2.3.8. And yeah, still something wrong here. Oh, it should be compile time.
Const val. It should be const val then.
Yeah, but it's most likely prohibited in Notebook. Yeah. So okay, I'll just write it here like this. And now I have a cater stuff, like I don't know, like HTTP client, which seems not resolved. Okay, remember, like there's a small thing like this dependency of multi-platform thing. Client from cater, yeah. And yeah, then I can create client and so on. So it's another way of specifying dependencies, but we don't need it for Dataframe. For Dataframe, you can do it like very easy. Okay, next cell. So there is a weather in Amsterdam, and it automatically read it from CSV and creates a Dataframe, reads CSV, and determines the delimiter of the file. And yeah, now I actually can see the wonderful output, which is Dataframe.
At this point, I have a question.
Yep.
So the way I look at this CSV file, there are numbers, there are dates, there are strings, numbers that are with floating point numbers, and so on. How does the Dataframe know which format should this value be, like which data type should it be, and how can we get a description of all that?
It's a nice question. First of all, I would like to answer to one question from the chat about like JDBC support. And actually, there is a JDBC support so you can actually read it from JDBC result set, for example. So you can like data frame read, and here are like lots of okay, it's SQL. Lots of SQL methods, like for example, you can specify the query, read the like table, or actually, and you can actually take any result set from JDBC and read it table format. So, but yeah, let's stick to our CSV file. And like now to your question, Anton. So if I have a arms weather, let's a little bit play with it and take a look at it. So first of all, it prints us that it has 212,000 rows and 24 columns. So we actually can like get it. Yeah, for example, row counts, and it returns the number of entries. Or you can, for example, specify it is like you can actually write it columns count, and it's 24. So if you write columns names, it will return a list of column names. And what is really cool, you can write column types. And actually, when you read the CSV file, it will automatically read the data and understand what's the data inside and parse it to like according to the format. So it's now like currently I can see that, okay, let's now just type schema and see that I have name, which is Amsterdam, and it's string. Then we have a daytime, which is local daytime, Kotlin daytime, and then temperature, which is always presented in the data frame because it's double, because there are, for example, double with question mark, and it's basically nullable double, and basically means that some data is absent, so it's like just was missed in the original CSV file, which is very handy, like, and we see it in future. So it's strongly typed data frame now. So let's like try to address some cells inside this data frame. And the simplest way, for example, is to address it like this. So if I write temp, then I get this column. For example, if I specify the index, for example, fifth element, and then I get this by 5.3, this element of my table. I can actually like do it like differently. I can say that it's let's first take fifth row, and then like use temp, and actually I get the same thing. The problem is that if you have lots of these columns, it's very like it's not really handy to specify it with a string always, like because you have specified. And what is also important, like at that moment, if we take a class of this,
okay, yeah, it might be nullable because it's like
yeah, so it's actually the thing is that it's something like nullable any, because we don't know like at this point what is actually this temp thing, because it could be any string, right? So yeah, that's why we have very innovative approach inside like Kotlin Notebooks for working with and Dataframe library for working with columns, names, and types. So you can address it like this, and it's called temp. Or vice versa, like you can like say temp 5. And you may ask, oh, wait a second, it was just like a string in the CSV a few seconds ago. Why now it's a property? And
interesting.
The thing is, this property is generated as soon as we get this weather variable. And this thing is this like behavior defined on the library side. So Dataframe can inject and run any code like after like you can actually like when you integrate the library with the notebook, you can actually have a hook, for example, on any variable creation of any variable. And as soon as you get this variable, you can actually generate the properties for the type of this variable. So if I click to this temp, it's actually just an extension property on the like some special type, which is like, and this weather thing is actually exactly a data frame of the same special type. And that's why you actually have a strongly typed access to our data frame now.
So
So, and
I guess
yeah,
it's the primary difference to when you are working with Python in notebooks, right?
yeah, in Python you actually like can do literally almost anything with your data frame, and sometimes it works, sometimes it breaks in the like middle of the execution, and also like, which is very weird, like at some point you lose the what's actually going on often because of I believe that our approach can lead to potentially way neater syntax than like in Python. But like you are actually you can actually compare. So if you know Python and you ever like played with pandas, you can compare. And we actually have these examples as well, like side-by-side comparison between pandas and Kotlin Dataframe. Okay, let's do something with this. First of all, let's probably describe it. It's very simple method. And yeah, so it actually calculates a new data frame which has some statistics over the original data frame. For example, like name is type of string, count is basically the same, and it has only unique value, which is Amsterdam, because I downloaded dataset for Amsterdam. And yeah, so it's 0 empty spaces, and yeah, minimum, median, maximum, more or less the same. Daytime, which is local daytime, and it's like it starts from 200 to 2000. What is top? I'm not sure what is top. So I know what is min. It started from 2000 1st January and ends in actually a little bit in the future, because it was together with some forecast as far as I understood. And yeah, lots of other stuff. For example, we can take a look at temperature and take a look at average temperature in Amsterdam, which is just 10 degrees. Not really warm place, so think twice before relocating here. But at the same time, and yeah, and minimum temperature was 17.5, which is, I can't imagine. And yeah, the maximum 36, which is also
Pretty
hardly
hot. Pretty hot.
Pretty hot. Yeah. So let's probably find when it was. So let's write something like this. So we can take weather and say like min by, and specify temperature here. So, and it's gonna be the entry with a lowest temperature, which was in 2012. If we click max by, we see that, yeah, this hot weather was quite recently. Yeah, and it was felt like 36.9, 38. Okay, so you most likely got the feeling how it looks like. Let's probably take a little bit deeper, and let's dive into something. For example, let's select some of the columns, which is like not really obvious operation and very important one. So we can select several columns. For example, I want to leave just daytime and temperature, and it will be something like this. So I just left 2 columns here. Or I can, for example, select everything starting from daytime and ending, I don't know, like wind direction. And here it is. So we have now a data frame with all these columns. We also can, for example, remove some columns. For example, we can remove, I don't know, like what we definitely don't need. We don't need name because it's always Amsterdam. And in the very end, we have like some stations. I don't know what is it. Most likely it's hierarchical stations, but I definitely don't need it. So, and frankly, the syntax of this selection is very like powerful. For example, you can select, I don't know, like let's select daytime and all columns of some type, for example, all double columns. And now I have daytime and all numerical columns. And or I need, like, for example, like daytime and all the columns about the wind. So let's say name contains wind. And now I have like only daytime and wind gust, wind speed, and wind direction, and so on. So, like, you may ask quite a valid question: why you actually like need it? So, and actually, how to understand this syntax of this library? So, if you go to Dataframe on the GitHub, there is a documentation link, which is quite extensive. And all the operations, for example, like creation, input, output, which we just used, or like selection, which is, operations, column selectors. And here you can see all the possible ways how to select. For example, select by name, select by range, by index, and many other ways. For example, take last and take 2, or take last 2, and many other ways. Later, like playing with Dataframe, you will understand why it's so important like to have this versatile syntax for column selection, because most of the operations, for example, like removing, grouping, updating, gathering, and so on, use first you need to select columns which you apply this operation for, and that's why it's very like important to have a handy way to select them. Okay, let's continue then. For example, let's do something now with rows, and let's select and filter some rows. So I'll take Amsterdam weather and say, let's take all the stuff for the last year. So I want to filter, and I need daytime with year equals to last year. And now we have a small data frame with 8,760 rows. By the way, let's calculate it. So it should be at 365 multiplied by 24, which is exactly the same. So we understand that we have all the data. And so what we can now do with it, we can, for example, like call it somehow. For example, let's call it last year. And now we can use this last year for future calculations and so on. We can actually reorder.
Maybe it's possible to somehow visualize and explore it and compare then.
Yeah, we will do it definitely. Let's first understand like the basics, and then we will definitely visualize it. So let's take this last year data frame. Okay, let's take first. I don't know, like it's important to understand like this data time here now is actually daytime, which is local daytime. So that's why I could take this year thing, which is very handy. Let's take something, I don't know, like let's take all the weather in Amsterdam and sort it by temperature descending. So now I have all the hottest days. Then I want to take, for example, take 30 of them. Okay, that's just a head of this data frame. And then I want to take, I don't know, distinct distinct years. So I can like say like distinct by expression and daytime year. And I see like it basically means that like all the hottest days were in 90, 18, 22, and surprisingly 6. But anyway, that some recent years were very hot, and like someone wrote, Yahar wrote in the chat that global warming is coming. So we can actually try to somehow check this hypothesis. But before we do it, like let's start with also one important operation which called add. So let's add some new data to our data frame. So for example, like let's take our last year and add a new column, and let's call it date. And then we can create some expression based on the other columns. So now I have this date column in the end, which is, it was year, but I need actually a date, which is like, that's why very important to have like it iterative, like, yeah, now I have date, and I don't need to recalculate all the stuff if I made a single mistake. That's why notebooks are very helpful when you don't know what you actually do, when you're exploring something. Okay, then, yeah, so, and we can, for example, say, move this column. Okay, move this column to left. Move to left the last, take last one. And now it's in the beginning. So I've added it here, and then I've moved it to the very left. So I don't need to scroll. Cool. And yeah, let's, for example, delete this name column because it definitely don't need it. And let's call it somehow, for example, wow with date. Okay, now I have this with date thing. Importantly, I can't address this date column here because actually it was created just like in the same expression. And it's kind of a problem in a long chained stuff. And we working now on compiler plugin that will create this data column right in the moment when it was created in the expression. But for now, you actually can use this column only in the next cell. Okay, I think it's time finally draw something. So we already use like have this Kandy library when we played with use routine. So now let's try to plot this with date thing. So we take this with date and click plot. And in plot, I can specify first some geometry, which I want to draw. For example, in that case, I want to draw temperature by date. Yeah, by date. So I can create a line for this. So it's very simple. Line X goes to date, and Y goes to temperature. So, and voila, now we got a chart. We can, for example, say that we want to also color for this. So we can write something like color red. Or we can also map the color, for example, to, I don't know, like, for example, humidity. Nice. We also can, for example, I don't want to like have this humidity thing like from blue to light blue. So I can specify scale for it. For example, I want to continue, no, just continuous scale, continuous, and it will be from color, I don't know, like green to color red. That's it. In most of the cases, my lovely vine is continuous color hue. Cool. Now I actually see that, for example, like when the temperature is very high, the humidity was quite low, which is more or less like understandable. And vice versa, when like the humidity is quite high, you can actually see that temperature goes down or something like that. But there are too many days in a year. We can actually make this plot a little bit bigger. Let's say 60. But it's still like pretty dense. The like valid question would be, okay, one more API, how to learn it. And good thing that for Kandy, we also have a wonderful documentation website with all the like two most important documents here is actually in user guide, quick start guide, with all the details about the documentation, plot creation, and so on. And my wonderful one is example. So you just like click on the chart you like. For example, I want this one. And then you have a snippet how it was created. So pretty simple and intuitive. Like fairly soon you will get used to the syntax, and it will be really simple and toolable, because like everything you have here in like code completion, which is all like quite nice. Anton, do you have any like questions that you think that important to ask?
I think there was one question regarding comparison to pandas, like in performance wise. Actually, a lot of questions about performance. Yeah.
Well, in performance is a tricky thing. Like because there are lots of different types of performance, right? So first of all, it's runtime performance. Runtime performance is quite competitive for the Kotlin data frame. So like it more or less the same like in pandas for many types of operations. In terms of different like ways how you well, in Kotlin data frame, in every single cell you can like carry any Kotlin object and use it. And it's not exactly the same in pandas and Python objects. So but on the like other side of this, you actually have lots of boxed objects from time to time, and that's why there's quite a memory footprint for some operations. But we are now working on like trying to make it as small as possible. For most of the data analytics stuff is like which I have, for example, the performance is more than enough. But like probably I don't have this huge data sets, but often for huge data sets you need like a little bit different kind of libraries, for example like Spark, and we have also like Spark API for Kotlin. And yeah, so if you have a really big data set, better to use a suitable distributed library for this.
Right. There was a question about that regarding like huge data sets, like how not to run out of memory for that.
Well, first of all, yeah, it's possible. On the other side, there are like some like things which I usually do. So first of all, default plugin settings here is quite low for maximum heap size. It was like 3 gigabytes or something, but it's in memory data set. So that's why I like just put it like 30 gigabytes or something. So you can set up the one that fits you. Basically, yeah, that's it. And let's then continue. There was a guess about global warming. So let's try and analyze the global warming thing. So let's take our Amsterdam weather again, and now we explore one more operation, which is called grouping. And it's called group by, and then I can specify what actually. Okay, by the way, let's create one more data set. I think it will be handy. So I call it with year and month, and it will be something like month weather, add, and here we will add 2 columns. Like first one will be year, obviously, and it will be from daytime year, and another one will be month, and it will be from daytime month. Cool. Now I have like the data frame with 2 additional columns. Again, in the end, I can move them to left if I really need it. It will be simpler. Take last 2. Cool. Now I have year and months separately. And yeah, now let's do grouping by year. Year. I don't have year here. Why? Oh, because it's like another data frame, and that's why like strong typing is really cool. So you actually, if you do everything right, you always like see it while you're typing. So if I group it by year, it will take some time. It's actually not because it groups slowly, it's because it renders slowly. and the performance of this will be improved in the next release. But yeah, good. Now I have this. So I have 25 rows now, each row for each year. And for each year, I have a group inside. Actually, the group, it's all entries from which has this value of year. So if I click on it, I go inside. So our data frame is actually our hierarchical. So in any cell can be data frame, which is very handy, and you'll see why. Because, like, yeah, you can actually do any kind of aggregation then. For instance, let's aggregate something, I don't know, like let's calculate mean temperature into mean temperature. Or, for example, I can calculate max. Okay, again, max temperature into max temperature. And when I like run it, I got actually like two columns with mean temperature and max temperature calculated for each year. So here I can write any data frame operations inside this aggregation, which is very handy because sometimes aggregations are very sophisticated. So okay, I got some like fairly simple data frame. Let's try to check our hypothesis about global warming. So let's call it somehow. Well, by year, and then draw it by year plot. This time let's use bars, and X goes to year, right?
Yeah.
And Y goes to, let's say, average temperature. How it's called? No, not average. Mean temperature.
Mean.
And well, okay, there are probably some trend, but not really big. We can
Maybe you
actually
can apply
add
some statistical analysis to show if it's growing or declining.
Yeah, we can do it. So let's first draw some line with max temperature, just to better understand what's going with extreme temperatures. Okay, it's a February, so let's probably just filter year not equals 2024. Nice. And but frankly, I like can't see any like significant trend, at least. But the thing is that even 1 degree is quite important. So we can try to build a trend indeed. So let's create one more. By the way, we can take this X here, because it's the same for both geometries we have, and like have it like in common. And if I'm not smooth line, probably it's called smooth line, and I can not smooth line. In that case, I really go to documentation and just like so statistical smoothing, and I need to smooth it by with a like simple line, probably, right? So it's called smooth line exactly. Yeah, so I was right. So smooth line. So x is a year, right? And y is mean temperature. And probably I see here I even can set up the color, which is color red. Phew. So now I have some smoothed, but if like I can specify, for example, the method, and it will be smooth method linear. So what's wrong with you? Okay. Yeah, now I have a line. Okay, line definitely goes up. That's because here it's 10.5 and here is 11.3. So it's like almost 1 degree higher than in the beginning of the century. Is it global warming? I'm not sure, but there is some trend.
Yeah. Nice. Well,
Yeah.
it's an answer. It's an answer to the question. Like, if global warming is a thing, it seems to be a thing.
Probably. I'm not sure that, like, as far as I understand, as far as I know, climate changes, it's something like 30 years and more. So it's not like valid to say about climate changes on this on such short periods like 25 years. So you have to analyze something like century, but we just don't have it in our data frame. Anyway, we get quite a result, some representation of what's going on. We can actually take a look not on the like I don't know, like middle thing, but we actually can try to analyze it like year by year. Let me show you something like this. For example, we can take our how it was with year and months, and then we can group it now by year, and now, like, if I do it, I get something like this, right? So I right. Wait, so
Loading data.
okay, because yeah, it's quite big. So we it's because it's not aggregated. So let's probably we need to aggregate it first. Right. So let's, for example, create this something like this. So we take this with year and months, and then we need to group it somehow because it's just like currently. Yeah. So like let's group it by year and group it. Oh my gosh, so many tooltips, and group it by month. So both of them. And for each of months, we will calculate, for example, mean temperature, like this. And yeah, so if I create it, now I get something like this for each year, each month, average temperature. So I'll call it now by month. And now I can try to draw this by month. By month, I will group it by year, and then I will plot it. So if I group it by year, it's something like this, right? So for every year, I have 12 months. And for every of them, I have temperature. So now I can like treat it as an individual data frame and say, let's plot it and draw a line with X, which is go to date. Oh, not date but month, and Y goes to this temperature. And now I have lots of years. Like, okay, let's add color to distinguish them somehow. Color goes to year then, obviously. Yeah, so for all the years, I now have this something weird with tooltips. I like have a line, separate line for each year, and I can, for example, add something like again some scale to actually see. Okay, let's add this scale, for example, to see them. For example, there is expectation that the higher is year, so the more red it, then should be it like higher on the chart. Frankly, I don't see it. So it more or less like the equal, I would say. So there is no like a significant trend, at least. But let's take a look at rains. Because in the original data frame, we had not only temperature, but also something regarding precipitation. And let's take not mean, but this time sum. So it's like total millimeters of rain during these months. And you see, like immediately, it's not valid now because now I have only precip. So yep, I can like have it like this. And so it's quite a mess. So let's filter, for example, for the last several years. Filter year is, for example, more than one, like this, and see the result. So our question was, is really this October and November are the most wettest months ever? And we definitely can see that precipitation like level was quite high in both of them, like higher than most of the months last decade. On the other side,
there is one spike in September in some year. I cannot see which one
what
it is,
is
but
also really thing that in 2006 it was like way higher, and 2004 and 2010 it was way higher in August. So it's like one of two. Oh yeah, and also like in the end of year, in December of 2001. So what does it mean? It meant one of two. Either like we have a bad data set, or the wonderful news on this NL times are pretty much
accurate.
Wrong.
No, wrong.
Yeah, they more or less like they similar to the reality, but like yeah, and actually there are like a little bit different numbers, to be honest. Probably it's because they have the station in somewhere like, I don't know, like where it was probably written here. I'm not sure. Probably it's another station or something like this. But anyway, like not everything so bad, but pretty wet and weird. Good.
Nice.
So we created this wonderful thing. I want to show probably several more wonderful charts, just to like show what else can be done. So first of all, do you know what is how it's called? Feels like, let me check it. Feels like temperature.
Yeah, I know. I live in
it's
Tallinn,
like
I know.
it's like salary, yeah. So when you get like 5,000 per month, and it feels like 3. So and with weather, it's probably more or less the same. So what's your expectation? What is like, how it's calculated? This feels like. Do you know the algorithm?
Uh, I have no idea. I can probably guess that it's related to the current temperature, humidity, and wind, maybe. And then you have some kind of coefficients that you combine into a formula, but I have no idea.
Let's try to understand it. I think it like would be a nice experiment for us. So let's take our last year, for example, and let's just try to like build a correlation between them. So I will just draw points chart with x goes to temperature and y goes to feels like temperature. There is. It's not really visible, so let's make it a little bit smaller, like 0.5. So it's pretty strange chart, right? Basically,
Looks
everything
very, very linear.
between 10 and 26.6, 27, it's actually equal. Like it basically means like temperature, exactly like it feels like. But there are two areas below 10 and above 27, which are different. So let's take a look at them. So you said that most likely it depends on what? Like humidity or wind speed. I think that when it's cold, it's definitely something about wind speed, right? So let's try
Should be.
because there is such wind index temperature, because I like yachting, and in yachting, like you study it a lot, so it should be about wind speed. So let's use then wind speed, and yeah, let's probably change the scale again a little bit, for example, for this rainbow one, and voila. So it definitely, we see that there are lines for different wind speeds. So depending on wind speed, you have different lines here. So, but we don't see something like this here. So it looks like this part is just like affected and by wind speed. And if I put humidity here instead of wind speed, then no any pattern here, but now there is a wonderful pattern here, and it's again lines. So it looks like that below 10 they use wind speed for determining the feels like temperature, and for high temperature they use humidity to calculate it, which is quite funny observation.
Interesting, very interesting.
What I'm really concerned is actually because this like thing is not how it's called, continuous. This function is not continuous, so there's a step here. So it looks like if there is a speed, then surprisingly, when you jump from 9.9 to 10.1, like feels like temperature will be like significantly changed, like for several degrees, which is obviously not true. So at least function which was used in this forecast and data set is a little bit strange as for me.
Too simple, maybe.
Yeah, probably. But it's a funny thing how like working with plots and like making some very simple observations, we can understand like the idea behind the data, which is quite nice. Okay, let's do something else. First of all, I would like to suggest our viewers to help us and say what they want to like us to draw, because we actually can calculate literally anything with this data, especially if you live in Amsterdam. You're probably interested in some like aspect of Amsterdam's weather. I would probably show something more. For example, let's take our let's calculate something about wind. So let's calculate the like the most, where are the most strongest winds in Amsterdam? So what directions are most often, and so on. So let's again take our last year as example, and this time we need to calculate. So what we have actually, let's take the data frame. So we have several things regarding wind here. So one of them is, let me check it. Wind gust is actually a speed on gusts, which probably is not that interesting. We also have wind speed and wind direction, which is just angle. And yeah, let's try to calculate it. So I would expect that the strongest wind is from the like north, probably, or from the like North Sea. So it should be northwest or west north, not something like this. So, but let's calculate it. So let's take it, and first we need to group by wind direction, right? So let's group by, and yeah, let's take a wind direction. The thing is that wind direction is quite granulated. So we have now 362. For some reason, not 362. It's pretty weird. So why it's 362? So it should be a 360. Why it's 362? Probably there are some
overlapping.
No, we group by it. So it should be like, probably we have something like, I don't know, like not integer. So let's take a look at it. Like let's comment it, and for example, filter wind direction. What's the type of wind direction, by the way? It's double. So okay, we minus wind direction round to int. So, and here we need ups, right? Less, no, more, bigger than 1 point, I don't know, something like this. Indeed, there are two entries with, okay, let's, I don't want to search it. Okay, with very strange wind direction. Good. So, okay, let's then group by such funny things. So we can, for example, by expression, which will be something like this. So we can take expression wind direction to int now, and then divided by 10 and multiplied by 10. So actually, I just rounded to 10. And that's it. Oh, by the way, it's now, like, because it was expression, it's no more wind dir. So let's call it the same way. Like, let's call it wind tier. Cool. Now I have wind directions, and in which direction, again, I have group with all the data, so I can calculate, I don't know, like temperature based on wind direction, but I want to calculate the mean wind speed, something like this. Cool. Now we have a data frame with average wind speed for wind direction. And now I can actually, yeah, and let's also probably sort it by wind direction, because now it's assorted. And yeah, something like this. Let's take a look at Kandy library and take examples and probably find something that we really...
So is there a wind map? There should be something like a wind map. No?
There's no wind map as far as I know. There is even at the moment probably no polar plot. But as far as I remember, there should be something like pi. Pi will be like perfect. So we actually have slices of different size. So we can just like do it like this. So, okay, it's probably a little bit dirty hack. It's better to use the normal polar plot, but okay.
It's a feature request.
Yeah, it sounds like a feature request. So, and we actually need to like say that size should be proportional to wind speed. And basically that's it, probably. Yeah, I got it. So there is our chart. We need to simplify it somehow, like, because first of all, I definitely need this wonderful legend. So we can just say that legend, I remember type is legend type none, something like this probably. Yeah. And also, yeah, let's say that we need to scale it a bit. So we want, because it's quite small, so it's 2 point. So yeah, so let's say that it's, for example, from 0 to 10. Oh, it should be double.
No,
it's 15.
Oh yeah.
Okay, yeah, something like this. So we can now also say that layout should be, I don't know, like size and to wonderful. And also probably add some colors. Color, fill color, which should be okay. Could be wind direction or wind speed, any of them. And probably in that case, definitely hue, which could be very effective. Continuously color hue. That's it. Wonderful.
Nice.
So now I like see that I can like have it. So there are two strong directions, yeah, from this side and from this side, which was absolutely unexpected from me, and really strong from the North Sea. But the one which is like the most common and most strongest from this side. We actually can check it for other, like not for last year, but for the whole weather. It's appeared that for whole weather, sometimes wind direction is null, which is like nice. You see, so you actually can sometimes see like the problem with your data. So you just can't create the wrong result. So you now have to deal with it somehow. So you have to understand that like sometimes there are some missing pieces in your data, and it's like completely different to Python. And let's, in that case, for example, say we don't want to deal with it because we need to somehow like fill the gaps, and we have to think about it. We can just create year 2022 and say that it was Amsterdam weather filtered, and year, no, it was daytime, right? Daytime year 2022. And now run it. And yeah, in that case. So it will probably more or less the same picture. Funny that not so really a lot from Norse, which is quite strange, but okay. We can actually play with it like further. Okay, 21. Yeah, quite funny. But more or less, we understand that the structure is like this, which is, yeah, wind direction 230. Yeah, it's exactly it. So yeah,
it's beautiful, beautiful, nice.
okay. One more thing, probably, if you're not tired, animation. Let's throw some
Animation,
animation.
nice, nice.
Yes. So I will probably just like take some of the charts that we already had. Like we somewhere had something for the last year. Like let's take this one. And it was like this. So let's draw it animatedly. So now we have color, humidity, and date. So let's animate it by date, for example. So what we can do here is we can write something like, we can create a function like draw before and pass some right okay, and date here, and it should be a local date. And then it should be something like this, but we filter this data frame, filter it by date, which is smaller than end date. And now we have a function that will draw not the whole chart, but the chart before some date that we pass. Okay, nice. So then we can create a plot. Let's take this function and use it. So we take, for example, our like, because it's already used some data frame, so we just like say draw before, and we take this this with date. Let's take a look what it was. It was last year. So okay, so it, okay, we can check just last year. Day max by daytime date. It probably, we also have date in this with date. Cool. With date marks date. Yeah, perfect. Now I got the whole thing. If I put, yeah, probably, yeah, min date, and it, yeah, it's empty. So, and yeah, let's try now animate it. So it will be a little bit weird, but the result is still impressive. So the thing is that the function called display, and it can display like anything, like for example, like this. So it just like displays, or I don't know, and it's so to have like several outputs, and it can display 10 afterwards. Oh, by the way, for some reason it doesn't work. 10 should be somewhere there. I don't see it. Anyway, the thing is that we can actually pass some ID here, and it's can be any ID. So we just like create ID with plot and say that it will be ID. Cool. At that point, nothing changed. But what we can now do, we can actually now create, like animate this thing. So we can, for example, create a variable out of it. This one. Nope. Okay. Yeah, I've forgotten the hotkey. For some reason, I do something like, no, it's
Command Option V for me, but maybe you have a different game app.
Probably just doesn't work. I don't know. Like, so let's create var for it and say it's right. And date, which is not draw before, but just this thing. No, now I can like draw before this and date. Nice, it still works. And then I will just in cycle, like while this and date is smaller than with date maximum date, I will update my display, and in this update I can actually pass the same ID, which is really cool. So I can like say draw before and date, and I need just increase end date. So this end date should be end date plus and remember date period. Yeah, so 0,
Month.
0, 1. Months or day or anything. So we can experiment. Why it's
I guess Max should take the lambda as an argument. No?
Oh yeah, sure.
Yeah,
you're absolutely right. Yeah, and let's have some thread sleep here. Just I don't know, just a small one. Let's take a look. Whoa, my! It draws, but like the structure is very, it's like strange. The question is why? Oh yeah, I know, because like there are like lots of points per day, so it's not per hour, but like all of them are per day. So we actually need to like, for example, group by date at first, which is by the way very simple to do. So we can yeah, now it should stop first because or we can stop it like this. Yeah. Nope. Yeah, we can. We can. So now with this date, we can, for example, group
by day.
By day. Oh, you got it. So we group by day and calculate mean temperature. Oh, group by mean temperature and humidity as we use it. Now let's take a look, and something is wrong. Love it. Column not found. Temp. It's funny why. Oh, because probably here we need to something like this. Nope. Okay, let's take a look what it will. And now it's a strong part of notebooks, right? So we can just if we have any problem with just like, oh, okay, so it's calculate, oh, min4 probably it's called. Yes, it's called min4. Because min calculates as mean between all the temperatures and humidity together. Nice.
Now it's one
Now
line.
we have a wonderful chart, which is animated. So of course you can like create a simple wrapper for all this structure. We actually will also create it in the next version of the kernel.
Well, there was a question I think that is related. If it like, is there a way to convert the snippets into a library?
Well, the simplest way that you can do, like, it's probably not about like library, but you can like just copy and paste all your snippets, like select several of them and copy and paste it to your simple code. But there are two aspects which are important. First of all, currently there is no like special like migration thing or something for this. And also the code which is generated between like cells is not also copied, which is a little bit not really like handy.
And all those property accessors as well that are generated from the data from the data frame, right?
They generated yes, exactly. So they generated between the cells execution. So what we can do in that case, so first of all, we actually can take like there is a way how to see this code. For example, like we can create there is a magic or something, and it's called trade execution. Probably you have to write something like this. Nope. Track execution. Yeah, just track execution. And now when I create something like, okay, I take my last year and say add some, I don't know, like column and calculate it with what I have here, like temperature. And now when I run it, I see nothing. Why so? Let me check. It's weird. Actually, I was expected that the generated code would be printed here. But I didn't test it for times, and like it seems it doesn't work at the moment. Or probably this track execution has like some different syntax. Like let's take a look at the documentation. So Jupyter, Kotlin Jupyter, track execution. Yeah, so if you create track execution generated, it should create it. But yeah, probably because of there was some bug with that when you print this thing. Like actually, we had the same issue like when we tried to use several displays together. So it's the matter of bug, but you can generate this code. Actually, for any data frame, like for example, you have this last frame, you can also just click generate interfaces, and it will create the data schema for it. And you can then use in normal Kotlin this data schema to type your data phrase, to type your data frame. Or there is also a method which is called generate. Oh, by the way, now it works. Executing, it shows what it executing. Generate. Oops, completion is off.
Okay.
Oh, why? Last year, generate code. And as far as I remember, yeah, it will generate the exact properties you need to type your data frame, and
Nice.
as well as a data schema. So like together, like in combination, there is a way how to like migrate your code from notebook to normal Kotlin code. We are also working on now like compiler plugin, and with this compiler plugin, everything will be even like way simpler. You just write this code, and it will evolve the schema on the fly. So you need to generate the schema only for the first data frame, and then it will be automatically evolves based on the like operation you use. But currently it's not available, it's still experimental, so stay tuned. But it's really like the unbelievable experience. Like I already tried it on several examples, and it's wow. So it's something like completely like new way of communicating with like your dynamic data.
Nice. Because
And
data
the other
can
thing that we are,
the schema can be dynamic, right? You can at some point you may add a new column, name it somehow,
Mhm.
and would expect that now it's referenceable
Yeah, exactly. So
in your
this code,
program.
for example, I don't know, like year, which is their daytime year will work. So I here can write year 2022, and this code will work. This year will be like already created, and it will understand that it's integer, which is
Nice.
quite magically. The other thing that we have in mind is actually have a like kind of intention, like smart migration from notebook to code. Like you just select several cells and say, please, like copy it to like move it, or like copy to some Kotlin file, and it will create the all necessary code, like combine several cells together if it's needed, like probably so it can be smart.
Nice. Nice. All right. I think we have done our best now, and it's almost 2 hours we are in the stream.
Oh my.
Yeah, folks are still following us. Thanks everybody for coming and staying with us and asking those awesome questions. And what let's summarize what we have covered today. I mean, like we made an intro into Kotlin notebooks, what you can do with that, and how to get started. We explored the data frame library and how to transform the data and add new columns, filter, sort, group by, aggregate, whatever else. And we have pretty good documentation for that. And we have seen nice, awesome graphs plotted with the Kandy library, right? And then you can take those notebooks somewhere else and share it with your team. I guess this is what you're
Exactly.
trying
That's
to
what.
show.
Yeah, that's what I want to show you as well. So you can then take your notebook, upload into Datalore, and run it. Or you can actually even set up the scheduler of running it. For example, there was a notebook where, like, let me show this notebook because I have it here. I created a notebook for analyzing our Kotlin YouTube. So I just like created like some cater, added cater dependencies, then created a client, then set up some like variables and so on. And then I like got this. Yeah, so it's like tedious, like lots of requests. So I got the list of the videos, created data frame of it, and for each video I've actually downloaded the statistics and like code snippet and so on. But like in the end, I like could analyze it again with the help of Kandy library and create a nice charts that now are always available as a dashboard on Datalore, which is runs once a day. And for all the videos we have here on YouTube, I can now see the number of likes, number of views, and the size of the circle is actually number of comments. So the most liked and the most commented video probably is about Kotlin Notebooks,
Kotlin
surprisingly.
Notebooks.
But the most viewed one is about building iOS and Android application with Compose multi-platform. And like we have lots of other videos you can analyze, which are more liked, more commented, and so on. For example, definitely context receivers got some attention. And also I've created several. You can actually render data frames also as a HTML table. So here are some HTML tables. I can click on any of them and navigate to the video, see and see it. Let's go back, and yeah, basically it's very simple, very easy, and everything created with the help of Kotlin Books, Dataframe, Kandy, and Datalore in pair with them, and everyone can like take a look at it. And yeah, by the way, some like time soon, we also have a small circle on this chart with today's video. So please click your likes on it, and we will see how it's moving. Comment it, so we will see how it move it slowly but steadily to the right bottom upper part.
Nice.
Yeah.
Cool stuff. I think this is where we can stop the stream and say goodbye to everybody. And well, as Roman mentioned, give us a like, comment something, and subscribe to the channel if you haven't yet. Right? So thanks, Roman, and have a nice Kotlin.
Thank you, Anton,
everybody.
and thank you for all our viewers. Bye.